Peter Bane is the author of the Permaculture Handbook, Garden Farming for Town and Country. Peter serves as the Executive Director of Permaculture Institute of North America, which advances solutions for an energy descent world, small-scale farming, family farming, reforestation for climate cooling, and ecological literacy across society. He will be speaking on urgent action for climate cooling. Please be sure to put your questions for Peter in the chat.
Well, good morning, all. Can you hear me?
We can hear you.
Very good. So I'm speaking to you from my home in western Lower Michigan in the territory of the Odawa and Potawatomi peoples, where it's an enticingly beautiful day outside, and I'm making large personal sacrifices to be in this honorable position with you all. I'm moved deeply, not only by my long association with the Arthur Morgan Institute for Community Solutions and my friendship with Susan Jennings and other members of the board and the staff, but just to hear the ideas that I've lived with for 30 some years as a permaculture teacher and designer taking form so beautifully and flourishing through the program activity that Susan's just described and shown to us. I think she and others with community solutions are living the truth that everything is connected. And this is not only the promise of regeneration, but the pathway as well. So I want to talk in my session here about something that connects us all in a multifarious ways, and that's the climate, and in particular, the destabilization of climate that human activity has brought about. So to get at that, we need to take a look a little bit at what are the fundamentals, why it matters. There's a lot of headlines around climate because of wildfires, hurricanes, floods, crop failures, and other calamities. And in fact, these are the real immediate threats that are coming about because the atmosphere is heating and the air and ocean systems are absorbing and holding greater amounts of heat coming in to the planetary system from the sun. Most of that is, well, I'll get ahead of myself here. I think I need to try to share my screen. So let me see if I can accomplish this. We're going to start here with a short take on what I have to tell you. We need to cool the climate even faster than we can sequester all the carbon that we've thrown up in the air. Eventually, it needs to get back to safe storage in biosystems, in the soil and in biomass. But before we can get there, we need to start actively cooling the surface of the planet. And the best ways to do that are through the use of water, soil, and trees. And the good news is that as we do that, we will also start to pull the carbon out of the atmosphere and put it where it can be really useful to us in soil, where it holds nutrient and makes more nutritious food available to us, potentially holds water, reduces runoff, and starts addressing all kinds of environmental and health and economic challenges as well. So what I have here are some simple examples of agroforestry and small earthworks and applications in both countryside and in urban environments where we can harvest water to make it available to grow and expand green growth vegetation across more acres, across more months and more seasons. That's our task. That's the actual physical land use aspect of repairing the world, which is Susan spoke about. Of course, we have to heal ourselves in the process. As we get out in the garden, as we get into the earth as a garden and begin to tend it, then we'll come back to a balance mentally, psychologically, and socially. But it involves us making cultural changes that will take some time. We will need not only psychotherapy, we will need to make conscious choices about the way we live and help others do the same. So let's see, where am I? Here. There we go. So now to take a big zoom look back and consider fundamentals. The climate that we're in is a consequence of tectonic changes that started or that took dramatic change about 3 to 4 million years ago, as the Isthmus of Darien closed and the gap between South America and Antarctica opened and the circulation of the oceans changed. It led to a regime of large ice sheets forming at the poles, and in particular at the North Pole over the Arctic regions, expanding dramatically out to the south in pulses that were mostly cold and lasted a very long time, 100,000 years on average, and that were briefly interrupted by short 10,000 year periods, what we call interglacials. These are warm spells. We're in one now. It started about 13,000 years ago with a little bit of a shaky start, and it would normally be coming to an end, but it's not. In fact, we're going off the charts in the warming direction because of human activities and interventions. We didn't know what we were doing when we started. We do know now what we've done, and the challenge is to become more adept at how we made the changes so that we can mitigate the changes that we unconsciously made to wreck the climate stability and bring them back to a more benign condition. And why this is important is because all we know about ourselves, our ability to talk to each other over this electronic medium, the food we had for breakfast, is all utterly dependent on 10,000 years of development of agriculture and urban civilization. And that rests on this foundation of a stable, moderate climate that came about because of these large geologic forces that we messed with. This is a little bit like the Sorcerer's Apprentice. If you think back to the Disney cartoon, you know, the apprentice sets something going that's cute, saves himself some work, he tells the brooms to start sweeping, and pretty soon they're carrying water and the whole place is flooded. That's kind of what we did when we started farming unconsciously. We don't have to give up farming, but we have to change the way we do it. So these images just show a set of cycles of glacial cooling and warming on 100,000 year intervals over the last couple million years. We used to think there were only 4 of these. We named them. They're a little different. You know, this was supposedly the Wisconsinian glaciation that just ended. But now we know there were 20. We have detailed information on 20. There might have been 50 of these cycles. And they're driven by 3 large solar oscillations. The Earth gets closer to the sun. It tips in certain ways. The intensity of the sun changes.
Oh, I think Peter froze for a moment. We'll give him a moment to come back.
Okay. Hear me. Mm-hmm. Is anyone hearing?
Yes, we can hear you now. Your signal from space was briefly interrupted, and I think you're stable now.
Well, I hope so. I'll try to carry on. So what we know is that a stable climate growing out of this warm period is critical to all we are able to do. And we've threatened it by changes in land use, accelerated by the discovery and deployment of fossil fuels that have put a lot of carbon from soil and from geological reserves into the atmosphere, increasing heat retention. But we are still accelerating the processes that created the problem in the first place. And we need, therefore, to change the way we use land and live on land. And principally, that means changing our agriculture. So something most people are unaware of is that North America is the climate flywheel of the planet. As climate goes through these large cycles, the ice sheets that spread out from the polar regions in the north grow much more dramatically across North America than they do into Europe and Asia, so that at their peak, the ice sheets over North America are larger than the ice over Antarctica today, millions of square miles, and they reached Yellow Springs.
Peter, we can't see your screen share at the moment.
I am screen sharing according to my computer. I wonder why.
Do you want to undo and then redo real quick?
I'll try it. Let's see. Is that better?
Yes, now you can see it. Thank you.
Wonderful. So North America is the climate flywheel of the planet. And those sheets of ice once covered me here or our territory in lower Michigan, and they reached all the way to Yellow Springs and even a bit beyond, probably about to Dayton and slightly south. There are reasons for that. The shape of the continent is one of them. Okay, let's see. Our unique geography funnels rapid movement of air masses north and south. So North America has not only dramatic politics, but dramatic colors in the fall and dramatic changes of season. Rather, we take it for granted, but it's a little unusual in planetary terms. And it's because North America is built like a funnel, and there's nothing really to stop Arctic air moving all the way to the Gulf and vice versa. It's flat. The mountains run north and south, and they have enabled our vegetation regimes to advance and retreat with the glacial lobes, so that repeatedly our hardwood forests have retreated to the Gulf Coast, and then they've advanced back north of the Great Lakes as we see them now. So what happens as the solar cycles that drive the climate go through their swings is that vegetation takes advantage of the changed environments, and it has an accelerating, interlocking activity with the cosmic cycles, the change of the relation between the sun and the earth. So that forests expand. As glaciers retreat, open ground occurs. Lots and lots of ponds and swamps and lakes are formed. The Great Lakes are a big example of that. So is the Black Sea, the Caspian Sea. And these areas become biologically active, and soon vegetation grows. And carbon dioxide gets pulled out of the atmosphere, and the climate then cools and it begins to reverse. Well, that's a hint, and the hint is that we're going to see more, we need to put more focus on biosystems and how we manage them. So the average correlations of all these cycles over hundreds of thousands of years show a pattern that's tied into forest growth and expansion and contraction. As forests advance, as temperatures warm, gas levels therefore show a pattern or a sequence from the decline of the ice ages to the onset of the next ice age. And because we've identified this pattern by averaging many cycles from ice core research in Antarctica, we can begin to see where they're off now in this warm interglacial particularly. Agriculture emerges with a distinct chemical signature in the ice cores. More CO2 starts to be apparent from about 7,000 years ago. More methane starts to be apparent than would be expected by the long, long sweep of natural processes uninterrupted by humans, breaking the pattern. And that pattern is agriculture. So we now have really fingered the emergence of the Anthropocene, of the geologic age dominated by human activity. 7,000 years ago, farmers on a very wide front across Eurasia started burning forests in order to clear land to grow crops. They had been dabbling in crop growing using open land, and then they put it together that, oh, there's good soil under trees. Let's get rid of the trees and grow the grain we are interested in. So we have a CO2 footprint that emerges. We were by that point already beginning the process of cooling. That is, the interglacial was already peaking and beginning to slowly deflate a bit like a balloon, losing its air. And if we had not been adventuresome in the way that our farming ancestors were, we would be well on into glaciation by now. It would be full on sometime now over the next millennium. In fact, in the early 19th century, it was incipient in the northern islands of Canada. There are discoveries of areas of lichen that were growing in the 18th century and then were snuffed out, not by volcanic action or forest fire, but by snow that didn't melt in the summer, which is sort of the definition of the forming of glaciers. The snow doesn't melt in the summer, it builds up, it increases, it becomes ice, it starts to flow, it eventually gets 2 miles thick. But that was interrupted as we expanded around the globe. We burnt more forests. Indiana used to have 2 billion trees, and in 1820 and by 1900, there was 10% of that left. It had all been turned into farmland, and it was being plowed, and the carbon was going up in the air in massive amounts. The industrial era hit. We turned away from slavery and toward fossil fuels in the middle of the 19th century. And suddenly CO2 levels start going off the chart. This is the story behind all of what we need to do. We started changing climate by how we cleared forests and began growing rice, meaning artificial swamps that generated methane. And we accelerated that process, and then we sort of retarded the onset of the next glaciation by agriculture. And then with industry and fossil fuel use, we drove it far away, maybe 50,000 years away. We don't know. We don't really want more glaciation right now. So part of that's a good thing, but we don't want runaway heating because it could drive us extinct. So we know from a number of intervals that correlate with historical knowledge that forest expansion cools the atmosphere. We have evidence from the 14th century with the Black Death, the bubonic plague, that killed 1/3 of all Eurasian farmers in a short time, in a generation, and corresponds closely to a decline in global temperatures that continued for about 500 years. We Europeans, went to the New World, to the Americas, bringing Old World germs, and that decimated a large population of American agriculturalists, native peoples in the Amazon and the Mississippi Valley, who were farming vast areas, and forests reclaimed those as the farmers died off from measles and smallpox and so on. This deepened the Little Ice Age, so-called, because it was a very cold period, memorialized in the paintings of Peter Bruegel about Central Europe in the 16th century. The Thames River famously froze, along with the canals in Holland. So we have the tales of Dutch children skating in the middle of winter on their canals, which don't freeze anymore. In any case, that forest expansion, which occurred in a matter of decades, corresponds closely to this cooling. It's another hint at what we need to do. If we need to cool the planet, we need to plant a lot of trees. But how do we do it? Well, we can see the flux that occurs annually in our climate system. And that is indicated here by the large numbers in the upper left hand of this chart. It says carbon drawdown, 7 parts per million. That happens about this time of year every year because the northern hemisphere has more of the land mass of the planet, and it's covered in vegetation that goes dormant come the fall, the time we're in. So carbon is released as biomass decays. And then come May next year in the spring, a large part of that is pulled back down, but because industry is contributing CO2 emissions, we're ratcheting up. So we have a little sawtooth graph there, which is from the laboratory on Mauna Loa that's measuring CO2 in the atmosphere and shows the progression up from below 300 in the early industrial era to over 400 today. Interestingly enough, most of us realize that about a quarter of that increase is an historical legacy from agriculture beginning 7,000 years ago. And 3/4 of it has occurred from the fossil fuel era. So we had a major impact already, just using literally our hands and stone tools and oxen and what have you, bronze plows later and so on, to oxidize carbon and change the atmospheric composition and increase exposure of soil and land to solar radiation, increasing re-radiation, and so on. So we've been heating by 2 processes. We've removed vegetation, we've allowed the dark soil and the dark land to heat up more, which it does as the 4th factor of the temperature differential. So you've all walked across parking lots in the summer and you know what this is like. You know, it gets hot enough to fry an egg out in front of the grocery store in July. And if you're in a cornfield in Ohio and you take the corn crop off in the summer, the soil goes from being a comfortable 68 degrees Fahrenheit to about 140. At 68, soil microbes are happy. At 140, they're dead. So they don't hold carbon, so things oxidize and leave. So we know that we have changed the composition of the atmosphere and we've heated the planet because of agriculture. And changing the way we manage our land would help us a great deal to reverse the processes that now threaten us. So there are several processes by which biosystems cool the planet. One of these I've mentioned, a couple of these I've mentioned, I want to detail them slightly. We need to cover soil and shade pavement in urban areas because they're capturing too much heat and re-radiating it. We wouldn't be heating the atmosphere as much if we weren't turning light into heat, but instead turning light into plant growth. Trees and other vegetation manage to turn sunlight into sugar and in the process transpire moisture, and they can release heat somehow without boiling that water. It's a bit of a miracle. We don't recognize it. It's going on under our noses or over our heads all the time in the growing season. We need to expand green growth so it goes on more over more larger areas and for longer periods of time. The short way to say this is, as a permaculturist, my ambition is to reforest the Sahara Desert and other deserts on the planet, not to settle for tinkering around emissions around how many carbon molecules come out of the tailpipe of automobiles, though we have to do that too. We need actively to pull carbon out of the atmosphere and cool the surfaces of the land in order to cool the climate to avoid the spread of wildfire, hurricane, storm, drought, and the insidious failure of our agriculture due to rising temperatures. Most of the crops we depend on don't grow well at 90 degrees Fahrenheit and above, and we're seeing those periods extended longer and longer in all our agricultural areas. So what happens here? We cover the soil, we grow trees. Soil moisture, which is our beginning point, and I'll get to this. It's where we begin, get water into the soil by holding back runoff. That supports plant growth. Plants growing transpire and release latent heat, which can rise through the atmosphere to the through the lower layers up to the stratosphere and be carried out to space, radiating and not heating the planetary system. Trees, in this
Oh, looks like Peter froze again, briefly. We'll wait for a moment for him to, his signal to come back from space, which he's talking about now. Oh, it looks like we may have lost Peter. Oh, we have lost Peter. Okay, well, we really appreciate Peter and all he had to say about our need to cool the climate, expand green growth across more seasons, across more of our minds as well, talking about the cultural shift that is needed in conjunction with the environmental shift. I think we're all feeling that, every one of us that are here today. We really appreciate Peter's ability to talk to us about that. Oh, it looks like Peter is back. Hello, Peter.
can you hear me?
We can hear you, yes.
Do you have time for me to say a little more?
Yes, it looks like we have maybe another minute, and then we maybe you can summarize for us about our needs.
Maybe I can. So I'm not sure if the pictures will help me or not, but what we're really looking at is increasing the movement of water from soil to sky, and in sort of an inverse way that will anchor more carbon and pull it out of the sky into the soil. And that changes with our land use, so that we need to incorporate trees in our farming through strip cropping, through agroforestry. We need to change grazing practices. We need to do many things in our urban areas that include retaining runoff in rain gardens and detention basins and green roofs, and using curb cuts to direct water that would go sluicing away and to get it into soil where it can then sustain an urban forest that helps cool our urban heat islands. So green growth is the key to changing and affecting climate, and we need to expand it in any way that we can. So I'm sorry for the technical difficulties. I hope you can hear me here. But what the promise of all this is, there are a large number of, there are good examples. Our own CCC during the New Deal era of the 30s, and more recently projects in Europe, Central Europe, and in India and in Africa are showing what can be done in the way of small-scale earthworks to harvest water as public works, as employment, as village and community self-determination, to create the future energy resources in the form of woodlands that we will need to replace fossil fuels as they deplete, and that will modify and stabilize the climate to benefit our agriculture, and that will create millions of good new jobs, not exactly in factories, more out in the sunshine, tending and caring for the earth, our only home. So I'd be happy to try to entertain any questions.
Yes, let's look for some questions. If you have questions for Peter, please put the questions in the chat here. It looks like we have a question about if you could maybe talk about Pina and your new work.
Yes, well, my My title now includes, I work with and for the Permaculture Institute of North America, which is a professional organization of permaculture designers, teachers, activists that stretches and serves across the USA, Canada, Mexico, and Central America and the Caribbean. And our effort is to improve the standing of permaculture in the public sphere. We've had 40 years of on-the-ground research, testing, grassroots education. Our ideas are sound. We have many solutions. They're not generally at the table when it comes to changing, although we've had significant influences. Permaculture people helped create recycling in the Seattle area when that was at the forefront of changing. We have influenced all kinds of movements, and we now see that the NRCS is teaching our soil model. I don't say that we own it, but it's the one we've been promoting for 30 years. So I'm happy to have Extension doing the work, the basic work of educating farmers and other people about how to care for soil. We need lots more of that. But we're still working at the cutting edge of biosystems understanding and trying to mobilize that information. So that's what I do, for PINA. It's a membership organization. You can find us at pina.in, and you can learn more about what we do. Let's see, other questions here. The PowerPoint I will try to make available, although we'll see how that goes. Not immediately.
We have another question about your home and where you're at now.
Yeah.
Bill.
Bill Cahalan. I know Bill.
Great.
Yeah, we've known each other for many years. I relocated beginning 6 years ago from Bloomington, Indiana, where I lived with my partner, Keith Johnson, to Western Lower Michigan, just a bit at the north end of Muskegon County, about 5 miles from the big lake. And we bought 10 acres here, a larger property than we had in Indiana, with more of a wooded component. And we built a solar home, and we've been developing a small farm. And in the last 2 months, my daughter, her husband, and their 2 boys have joined us here on the farm, and we're in the process of acquiring the 7 acres next door for them, with a house on it, so we can expand into more agroforestry management and local vegetable production and poultry and so on, kind of thing. So I'm very happy about that and eager to be engaged in that primarily, but also very glad to see people who are here. So for someone, Eunice Breivik writes, for anyone with a suburban home, what would be the first few steps toward helping cool things? Well, there are a lot of steps, and holding water in the landscape is one thing you can do. Small ponds are extremely effective at helping stabilize microclimate, as well as creating habitat for pest predators like amphibians and birds. You want to think about how and where you can grow trees and shrubs, perennials, in a small landscape that they need to be edible plants as much as possible, and multifunctional plants that you can chop and drop for mulch, for compost, for soil feeding, and that also give fruits, nuts, or forage for small animals. Mulberry is a brilliant example of a tree that children love and poultry eat because of the high protein content, has many seeds, that's impractical to harvest all of. So you need animal allies that brings in birds and thus nutrients in the form of nitrates and phosphates from the surrounding area, that has many uses, high fuel value. Everything eats it. Feed it to cattle, feed it to chickens. There's a lot of steps we can do. And I've written about that in my book, which Dawn mentioned at the beginning, the Permaculture Handbook, Garden Farming for Town and Country. Yeah, thank you. You can find it online, learn about it, see a little bit. there's some clips of me talking to various groups at this website, Permaculture Handbook, that detail what I thought the future would bring. And I'm 10 years on from some of those, and now we're sort of manifesting it. But all of us need to be getting on that train somewhere or other. Whatever land you have control over, try to get it more growing trees without compromising the ability to grow food. Those are the challenges we face. Ecosia is a search engine that uses ad revenue to fund tree planting. I have come across Ecosia in the past, and I don't see anything wrong with what they're doing. It needs to be expanded. I'm glad they're doing what they're doing. PINA is also trying to launch a program, a research-based program to plant 1 million trees across North America in different environments. But our interest isn't so much as, like flagship projects like, oh, this is great, let's have trees in Louisville because they don't have enough in these neighborhoods. That's needed. But we need to know, what trees are needed in the Kentucky region, what trees are needed in Utah, what trees are needed in Alberta, what trees are needed in Nicaragua, what guilds of trees and supporting plants go well together, who's got the nurseries, and how do we mobilize the community planting and care teams for care over generations. So that's the purpose of PINA's Million Tree Challenge, as a big experiment, because we need to expand from 1 million trees to 1 million forests. And we don't get there all in one step. We got to take some baby steps.
Well, I thank you so much, Peter, for all of your insights and your brilliant presentation today. I think that we've all come away with this with more knowledge and understanding, and certainly connection. Your talk was both practical and also aspirational, and kind of put me personally in this space where I feel like I'm part of a longer lineage of what needs to happen to move toward millions of forests versus just my own backyard. And that I can take part in that. And that's very inspirational and aspirational.